On this DeBacco University video, I'm going to go over the properties of liquids and how they relate to things that you might be exposed to every day. Now, we may have seen this meme where cats are liquids. Liquids do take the shape of their container while maintaining consistent volume. That's true. This picture might be a little bit of an optical illusion considering we're classifying a cat here as a liquid. We'll get into some of the key properties here of liquids though. So what are some of those properties? Well, liquids, particles are close but mobile, allowing intermolecular forces to regulate their interactions. Surface tension and capillary action depend on cohesive and adhesive forces. I'll talk about each of those in a little more detail. Viscosity does reflect internal resistance to motion, as you can see here with the thick honey being poured to the spoon and ultimately into the shallow dish. Now, what are some characteristics of liquids in general? Well, looking at their volume, it's defined, and their shape is kind of undefined. Liquids do maintain a fixed volume, but take the shape of their container. They're also, when we look at the compressibility of liquids are nearly incompressible, meaning their volume changes very little under pressure due to the closely packed molecules. We can kind of see that represented here. Put more and more force and it doesn't really crush. The ability to diffuse, so liquids can mix with other liquids through diffusion, through a process is slower than gases due to the molecular proximity there. You can see here some food dye being added to clear water in a flask. We see that diffusion occurring. Now, surface tension is key for liquids. Surface tension is the property of liquid surface that cause it to behave like stretched elastic membrane, essentially. This is due to the cohesive force, such as hydrogen bonds, between liquid molecules, causing liquids to form droplets or resist external forces. So what we can see here, this is water molecules, these little partial positives and partial negatives form these hydrogen bonds, kind of allowing our molecules to kind of stick together for a little bit and then breaking and reforming, and this is what's causing surface tension. Now, surface tension in action, where you might be familiar seeing it, water striders walking on water, water forming spherical droplets on a waxed surface here, such as a leaf, the cuticle of a leaf, and a needle floating in water despite the needle being denser. It looks like, it's almost like a plastic surface, but if you go really close and those bugs are small, seeing a little depression of that water, but that surface tension is able to act as enough force to hold that insect up. Now, capillary action, this is where we're looking at the ability of a liquid to flow in narrow spaces against gravity. And what this kind of image shows here is we've got tubes of ever decreasing diameter. So this is possible due to the distance between the cohesive forces of the liquid, within the liquid, I should say, and the adhesive forces of the liquid to the surface. And this is why if we're measuring liquids in, say, a graduated cylinder or a test tube, there'll be a meniscus. We'll see with water, we'll see this kind of U-shaped bend that we see to that. Remember, we always want to measure at the apex of that meniscus. If the liquid's adhesive forces with a solid, for example, the glass, is stronger than the cohesive forces, the liquid climbs up the surface of the container, forming that concave meniscus in water in a graduated cylinder. And you might see that when you're trying to measure something very precisely. If cohesive forces dominate, the liquid may depress, forming a convex meniscus, and this is an example here of mercury. The movement of the surface tension pulls the liquid along the solid surface, causing kind of like this kind of more of a convex meniscus. Now, we won't work a lot with mercury for obvious reasons, but still, if you were to measure that, or if I give you a picture of that, you're still going to measure at the apex of that meniscus. So what are some examples of our capillary action? Well, water rising in the glass tube, as I showed you, water moving up plant stems. We can see that here. That's to help that water go through the process of transpiration, while those kind of adhesive cohesive forces, capillary action, is allowing those water molecules to be easily carried up that stem. And a paper towel absorbing water as well. Now, cohesive, remember, is two molecules of the same type being attracted to one another. Adhesive, think of like tape or an adhesive. That's where one molecule is attracted to something other. And then surface tension is where they kind of come together at the surface and they're providing a little bit of a force that needs to be broken or depressed. Now, viscosity, kind of what I showed you with the honey picture, viscosity is a measure of a liquid's resistance to flow. It's determined by the internal friction between molecules. Liquids with strong intermolecular forces, such as honey, has a high viscosity. That means it flows very slowly. If it's got a weaker viscosity, for example, water, it flows very easily. Viscosity will decrease with higher temperatures as molecular motion increases, and that will reduce the friction. And viscosity does impact fluid dynamics as well as lubrication. So if you've ever gone through and you're trying to look at oil for a car, for example, this is where you might see this in action. Honey with a high viscosity pours slowly compared to water with its low viscosity, and motor oil's viscosity affects the engine performance. A lot of times you'll see these oils with basically two numbers, 15 W40, 0 W40. That's referring to the winter rating when we have those lower temperatures, and then it refers to basically the other number without a letter after is the hot rating. And that W, again, that trace just for winter, and then that's those lower numbers will be a little thinner, those higher numbers will be a little bit thicker. So you might want to check your owner's manual to see what motor oil they're recommending for the winter rating as well as the summer rating, because again, that temperature does have an impact of that. And if you use something that's out of what's recommended, the viscosity may not match the internal components of the engine, and you may not get the adequate lubrication and could shorten the lifespan. So this is an example how properties of liquids and viscosity in particular can relate to things that might be right around you now.